equations. I know I'm a math teacher and I like math, but I particularly like this unit. I just find it's very it's like very step by step. There's not a lot of curveballs with it, not a lot of itsy bitsy pieces to remember. It's kind of, I just quite like it. So we're going to start off with an exploration. So the Smith family and the Harper family are going to a book fair, raising money for charity. Mr. Smith pays entry fees of $11 for 3 adults and 1 child. If we were to write this first sentence, $11 for 3 adults and 1 child, as an equation, a possible equation would be 11 is equal to 3a plus c. Would you guys agree with that? Yeah, like that makes sense where I came up with that. Mrs. Harper pays for entry fees of $12 for 2 adults and 3 children. So slightly different scenario, or amount, I should say, same scenario. So her equation would be 12 is equal to 2a plus 3c. We can determine the cost of an adult ticket and the cost of a child ticket by forming 2 equations and graphing them. We've already formed those 2 equations. I used A and C. Your workbook is using X and Y. I personally prefer to use letters that have like meaning versus X and Y because it helps me not make mistakes, but really it doesn't matter. So they're saying X is the entry fee for an adult. So like adult would be our X-axis. And then our Y would be our child. So our equation 3x plus y equals 11, just like our first one that I used A and C for. If I want to graph that without using technology, how do I graph an equation when it's in this form? You all just did like 3 assessments on this type of thing. You should be able to do this. Good, we need to solve for y, so that way we can figure out our x and y intercepts. So I'm going to subtract 3x from both sides. So we have y is going to equal negative 3x plus 11. And that's the Smith family. So when I go to graph that, I have a point on my y-axis at 11, because that's our plus b, a slope of negative 3. So I'm going to go down 3, and then 1 to the right. And I have a point down 3, 1 to the right. I'm going to go all the way until I cross my x-axis. So I have an equation like this. Our second equation is for our Harper family. And that was 2x plus 3y equals 12. Slightly more difficult to solve for x here. If I subtract 2 x's from both sides, I'm left with 3y equals negative 2x plus 12. Divide by 3. So I have a slope of negative 2/3. And plus 4 is my y-intercept. So I'm going to graph that one. So plus 4 is my starting point, down 2, 3 to the right. Our 2 graphs cross. The point they cross at is at 3 and 2. So what's really neat about this unit is we're given like two scenarios. We can use those two scenarios, graph them, and they cross at a point. The point where they cross, we use a couple different terms to explain it, but we would say 3 and 2, so those sets of coordinates satisfy both equations. So remember, the 3 represents, or our X represents the cost of an adult ticket. So then the 2 represents the cost of a child ticket, or our Y. And so by using those two pieces of information, we found the exact dollar amount that I can plug an X and Y in to make the amounts work. Because remember, originally we were told that like the Smiths had 3 adults and 2 children, 3 adults and 1 child, versus the Harpers had 2 adults and 3 children. So if we plugged in 2 and 3 into those blanks in our equations, we would get the correct dollar amount. So the point where the 2 lines cross is a point where it satisfies both equations. And so it kind of proves to us that's the dollar amount for them going to this book fair. Turn the page and we'll go through a couple more examples to explain why this happens. Because it's kind of weird to understand, but at the end of the day, you're going to graph and see where 2 lines cross. That's this whole unit. There's 3 different ways to do it. One of them is graphing, but we're going to find where 2 lines cross. So this first little blurb here is explaining what I just said verbally. Couple key points. So if we consider both of these equations, there's one solution at 3 and 2. So we call that our solution, is another term you might see it. You could see it as a solution to the system of equations, or sometimes we might say it satisfies both those equations. So just different wording for the same thing. So in the first example here, they've got some graphs that are a little bit hard to read, but they cross each other, these 2 graphs. They specifically cross at this point right here, which is at 2 and -1. So the solution keyword to this system of equations, which are the 2 lines, which we don't know what the equations are here, but we know the graph of them. The solution's at the point 2 and -1. So wherever they cross, that's your solution point. Let's go through this example. So graph the system without using technology. So to do it without technology, we have to solve for y. So we have 2x plus y equals 2. Solve for y by subtracting 2x on both sides. So that's going to be our first line. So I can go up 2. My slope is a -2, so I'm going to go down 2 and 1 to the right. Down 2, 1 to the right, down 2, 1 to the right, or up 2, 1 to the left. So I get this line. I'm going to try and draw a straight line. That's not straight. Second one is a little bit trickier, so it's x minus 3y equals 15. So I'm going to subtract an x from both sides. Negative 3y is equal to negative x plus 15. Divide by negative 3. My negatives cancel out on the first portion, so I get 1/3 x minus 5. So crosses at -5. My slope is 1/3, so I rise 1, I run 3. Or down 1 to the left 3. And I find that the 2 lines cross. So our solution is the point that they cross at, which is at 3 and -4. So at that point, at 3 and -4, I can plug those two values, my x value and my y value, into both equations, and the equations will both work. So it satisfies the equation. It's our solution, just different wording for it. Then it says, algebraically verify your solution by replacing the values in the original equations. Oh, sorry, Camden, go ahead.
On like it says -3y equals -x plus 15, like when times the x onto the other side. Does it matter like if we do -x plus 15 or 15 times x?
No, it value-wise, no, it doesn't matter. But in math, we always want to put our variables first. So just like in English, we should spell correctly. We should put our variables first. That's one of those kind of gray areas. Like the value of it, no, it doesn't matter, because at the end of the day, I'm subtracting things. But just notation-wise, you want your variable first. Okay, so algebraically verify the solution. So if we plug in those numbers, it should work. On your investigation that you guys did yesterday, you had to plug in your numbers and verify your rules. A lot of your notations, like I'm not marking your notation on those, but like hurt me a little bit. So that was the last question on each set. So this is a similar idea. So if I go 2x with my original, I should keep my color coding. If we use our original equation of 2x plus y equals 2, if I plug in that 3 and -4, it should work. So 2 times 3 plus -4 hopefully equals 2. 6 minus 4, does that equal 2? Yes. Plugging it into, it said both, so I'm going to plug it into both equations. So our second equation was x minus 3y equals 15. So 3 minus 3 times -4 equals 15. So then 3 minus -12. When I subtract a negative, I'm really adding, so I get 15 equals 15. By doing that, you are verifying it. Okay. Our next question we're going to use your graphing calculator for. So if you have it, pull it out. If not, that's fine. You're not learning anything new right now. So this first chunk I've already taught you, but we're going to do this example. If you have to go grab it, go grab it. So at the bottom of page 615, we're using that same example of the fair with the Smiths and the Harpers. We've already solved for x and y. Remember, to use your graphing calculator, your equation always has to be y equals, because that's how your calculators are set up. It's a limitation of your graphing calculator. So we've already solved this earlier on. This first one is going to become y is equal to -3x plus 11. Our second equation is y equals -2/3x plus 4. We did that on the first page. So in your graphing calculator, you're going to enter these into your y equals, just like you've done the last two kind of units. So make sure you're using your negative sign. So I get -3x plus 11. My second equation is -2/3 x plus 4. It depends on the version of your calculator. The older versions you need to. The newer versions, I don't think you need to. I think you're okay not. Camden?
I have a question, like this isn't now, but I remembered it. Like, how do you put like it's like y equals 3x? Like, how do you put an x and a y, two separate
It's always y equals, like the y is already there for you. So you only have one variable.
Do multiple variables or must you either?
No. We also though won't give you questions with multiple variables. Okay, so once you plug it in, let's all just go to our window settings. Make sure your window settings are standard because who knows where you left them. They could have like a couple hundreds in here. So we want to go back to our -10, 10, etc. Then we're going to go graph. So you've already learned this. This is just review. How do I find where those 2 points cross? Do you guys remember? Go ahead, Matt. Good. Second trace down to number 5, which is intersect. Press enter. You're going to see a little cursor. Notice right now, grade 10s on my screen, I don't actually see my cursor. On the bottom, it tells me first curves at 0 and 11. So that means my cursor's slightly out of the screen. It's slightly high. So if I go slightly to the right, I see it come down. Press enter, make the 2 points where they cross. So you should find the same intersect point that we have previously, okay? So it says, let's review. Data suitable window settings. Remember with our window settings, you list them just like they are on your calculator screen. So we did -10, 10, 1 for our X windows or our domain. Our Y windows were also -10, 10, 1. Could you put different things there? Totally. But with those window settings, we could see our y-intercepts, we could see where they cross, which is the biggest point right now, is we want to see where those two graphs cross. By using the intersect feature, we found out that they cross at 3 and 2. So we confirmed it. It's like, I would say slightly easier. There's less to remember.
The first one was the easiest.
Turn the page. Turn the page. Okay, so grade 10s, we're going to do one more example with your graphing calculator. So this unit brings a few pieces of our previous units in, but not everything, which makes it a little bit easier. There's not as much to remember, like with general form that you can have fractions, a has to be, like there's not all those tiny nuances, which is easier. So let's look at this example. So solve the system is what it's going to say. I'm going to tell you in most cases how I want you to solve it. Currently, we only know by graphing. Eventually, there'll be other methods. Sometimes I might just say solve. You can use whichever way you want. In order to solve by graphing, you always have to solve for a variable. Like generally, it's y. It has to be in the format y equals. In this scenario, I have a's and b's. It doesn't matter which one you solve for, but you have to solve them both. So let's solve for b. By doing so, we're basically saying that b is equal to y kind of thing. So instead of my y-axis, I'm going to label it with a b. My x-axis, I'm going to label it with an a. To solve for b in my first equation, I'm going to subtract 6a from both sides. So then I get 7b equals minus 6a plus 5. Divide everything by 7. So my slope is negative 6/7 a plus 5 over 7. That's our first equation. Yes, there's fractions, but that's okay. Our second equation, I'm also going to solve for y. Sorry, solve for b, my apologies. So I currently have 3a equals 14b. Generally speaking, we always see our y on the left side of our equal sign. So I'm just going to flip-flop this to make it 14b equals 3a. It's more friendly to me then. The only reason. Do I need to do that? No. Divide both sides by 14. So then b is equal to 3 over 14a. Okay, I want you to plug both of those into your graphing calculator. So y equals make sure you're typing it in correctly. Be extra cautious with fractions and with your negatives. What are you guys doing? Why do you have drumsticks? Okay. So when I go to graph it, my calculator shows it like this. Yours should as well. That being said, I actually want to zoom in a little bit more because I can't totally tell where they cross. So you can just go to zoom and then zoom in. Or zoom fit. Then you have to press enter and it'll zoom in better for you. Or you can actually change your window settings. Couple options. Then grade 10s, you really need to follow along right now. So now what we're going to do is we're going to go second trace down to number 5. Intersect. Enter. First curve. Enter. Second curve. Enter. And then enter again. We get some gross fractions. Or decimals. How many of you recognize what your x value is? 0.6666 repeating is what is a fraction? Good. 2/3. First curve, press enter. Press enter 3 times, basically. You want the cursor to be relatively close to where they cross. Usually it goes there anyways, though. So, grade 10s, say you didn't know the value here. What you're going to do, and we're going to follow these steps really carefully, and this is what's written above where it says note with the little policeman. So for the x coordinate, you're going to press clear twice. So you go to your main screen, and then you're going to press that xt button, your variable. Then you're going to press enter. So it imports it from your graph there. Then you're going to go to second, math. So it's below the green alpha button. Sorry, you're just going to go math. My apologies, no second. And go to frac. That stands for fraction. So it's going to convert that answer to a fraction for you.
How do you get the other one now? Right. 0.14.
So for the y coordinates, you're going to go alpha, 1. So then your y coordinate goes there. Press enter. Then you're going to go to math, frac again, and it puts it as a fraction for you. Math frac is a super helpful thing for your next 3 years. So our coordinates are at 2/3 and 1/7. So it says list your answers back in your workbook as exact values. Whenever it says exact values, that means a fraction. That's a hint for you. Usually, if you get a whole number, it's not even going to bother saying as an exact value. It'll just say list your values. So, right, use the hints as you get them. So we have 2/3 and 1/7 are our coordinates where they cross. Then it says algebraically verify your solution. So we plug those into our equations. So let's look at our first equation of 6a plus 7b equals 5. I strongly suggest you always plug it into the original equation, not the version where you solve for like y, or in this case solving for b, because that's going to help you catch if you made a mistake. Realistically, if you didn't make a mistake, it doesn't matter the form you plug it back into, but it's just kind of as an extra check to help you if you made an error. So remember, a was our x coordinate. So I'm going to go 6 times 2/3 plus 7 times 1/7. Hopefully that equals 5. When we're multiplying fractions, think of this as like 6/1 and 7/1. 6 times 2 gives us 12. 1 times 3 gives us 3. 7 times 1/7, I hope you guys can all just know that that's 1. Right? My 7s would cancel, my 1s would cancel. 12 divided by 3 is 4. Is 4 plus 1 5? Yes, so we didn't mess up. What's nice about this unit, you will always know if you made a mistake or not. That being said, sometimes you can't find your mistakes, so it's not always reassuring. Yeah, that's exactly what I already said. Just for the very last step. Just that last step.
I did that. Yeah. Yeah, I just inserted it into like the number.
Yeah.
Yeah. That's not that.
This, it's the same thing. So on my second equation, let's review a little bit of shortcuts with fractions. If I have a 3 in my numerator and the denominator, those are going to cancel. So I'm just left with a 2. 14 times 1 is 14 over 7, which reduces to 2. By all means, grade 10s, I would hope you could go directly to this step, skip that middle one. Same thing on this, our first example. I would hope you could go directly there. I'm showing you the extra steps that I think you should be able to do in your head at this point. If you can't, write it out. That's just fine. If you're prone to making little mistakes, write it out. That's just fine. But you should be comfortable enough with fractions that you're able to do that in your head with ease. Okay, so that's our first method for solving a system of equations. And then I have some practice questions for you. It sounds like more. They're level 1, 2 questions, guys. You can do this. You have 10 minutes.